Question 1. Okay. This question is about the reactions of alloy, the brass with the nitric acid, which produce a solution. And in the brass, there are copper and zinc in there. And we need to get the percentage or the amount of the copper too in the last part. Okay, so let's start from the step 1. Weigh a glass beaker and record the mass. After that, add 1 gram of the powder brass to the beaker and record the mass of the beaker and the brass. Okay, after that, transfer the alloy into the this conical flask A with the excess concentrated nitric acid. Then immediately this alloy, it will react and it will form the copper 2 solution. And okay, step 4 is very important because after the brass transfer to the acid, so we need to reweigh the glass beaker with the residue. So the mass difference between this and the previous one will let us know the actual amount of the brass getting to the acid. And for the step 5, I will use this part to explain, which is faster. Okay, once the solution is being prepared, the copper 2 solution, then we add sodium carbonate to this mixture, and it will form the copper carbonate, the precipitate. Then we add ethane dioic acid to the solution to dissolve the precipitate. So once the precipitate is dissolved, then we need to pour the solutions into the volumetric flask, 100 cm3, and after that, top up to the mark, to the calibration mark. So it will be solution B. So the solution B now has 100 cm3 of copper 2 solution. So we take 10 cm3 from the solution B, or to pipette 10 cm3 to do the titration. And of course, this solution B need to mix with the Ki. So the iodide here will immediately react with the copper 2 to form the iodine. Then together with starch, so means when you add the solution B to this Ki with starch, then immediately you see blue-black. Then titrate with the sodium thiosulfate, the end point is the blue-black disappear. This is roughly the reaction. And okay, for part A, the reaction involve reaction 1 and 2. Zinc and copper, their reactions with the concentrated nitric acid is quite similar. It will form the salt NO2 and H2O. The NO2 is the brown gas, the nitrogen dioxide, so it's a toxic gas, not good. So whenever there is a toxic gas, so the experiment is better conduct in the fume hood. Means everything's do in fume hood, then it's safer. Right, so suggest why step 3 in experiment should completed in the fume hood, because NO2 that produced is toxic gas. Right, so the fume hood it has a suction, so it will suck out all these toxic gas. And part B, explain why glass beaker is reweighed in step 4. This one I told you already. We want to make sure the accurate mass of the alloy get into the acid. Right, so because we need to use the sample, means the alloy with the beaker minus the residue with the beaker, so we get the actual mass of the brass get into the acid. Okay, part C, name a suitable piece of apparatus to transfer 10 cm3 for the titration, 10 cm3 of the solution B for titration. Because it's used for titration, it must be accurate volume, so we better use pipette. Nowadays, try not to just put pipette, include volumetric there, because volumetric there is a scale there. So 10 cm3 volumetric pipette, so to take this sample. Identify the substance used to rinse the burette. So we must use the thiosulfate solution to rinse the burette before titration. Then is better to remove impurities, at the same time to make sure the concentration is there. Okay, part E. In step 9, 0.06 mole per dm cube sodium thiosulfate is used, and this solution is prepared from a more concentrated one, which is 2 mole per dm cube, and describe how you make 100 cm cube standard solution of 0.06 mole per dm cube sodium thiosulfate from the more concentrated one. Okay, this one is obviously a dilution. So before you explain or give the answer, you need to calculate and get the volume of this 0.2 mole per dm cube sodium thiosulfate solution. Okay, let's say now we use M1V1, M2V2. So 0.2 is a more concentrated one. V1 is the volume we need to get. And this is the solutions that we need to prepare. 0.06, okay, and is in 100 cm cube. So rearrange, you get the volumes that need to be taken is 30 cm cube. So we need 30 cm cube of this solution. Okay, once you calculate, then you can go to this part. Okay, so how to take this 30 cm cube? We must use the burette. Okay, burette, or you can say 50 cm cube burette, to transfer 30 cm cube of 0.200 mole per dm cube sodium thiosulfate solution. And this one, it must put into the volumetric flask, not conical flask, not pickle. It must be volumetric flask because we prepare a solution. After that, top up the VF, means the volumetric flask, to the calibration mark. Because in the volumetric flask, okay, it always has a calibration mark here on the neck. So we just need to top up using this flask using distilled water, right? So the distilled water must be there. Don't just say water. Okay, top up the flask with distilled water, and of course it must to the calibration mark. Okay, once it's done, then you just put a stopper, invert this VF, shake and homogenize the solution. Okay, that's a step. Part F. So table 1.1 show the mass of pickle, the pickle with the this alloy, the brass, and the mass of pickle with the residue. So to determine the mass of the powder brass get into the conical flask A, we just need to use the last mass and the second mass. So we use the second mass minus the last mass, we'll get the actual mass that get into the acid. So which is 1.00 gram. Okay, in G there is a table, titration table, 1 rough, 3 accurate titration. And the final initial all given. You just need to use final minus initial, you can get all this value, right? Okay, after that, part 2, calculate the suitable mean title for this calculation. We no need to take the rough, and we just consider accurate. So because there are 3 accurate, and we must choose the nearest one. The nearest is this one, 20.30 and 20.40, and their difference is same or less than 0.1. So means these two they are the one that you need to use for the mean calculation, right? So you eventually get 20.35. Okay, then calculates the percentage error for the titration tree. Okay, titration tree, the volume is this one, 20.40. Then you need to, because there are 2 readings here, 1, 2. So you need to use the uncertainties of the burette, which is 0.05. So it's half graduation of the unit. So means you need to use 2 times, okay, times 0.05 over 20.4 times 100%, you should get 0.49%. Okay, so for part H, this one is a normal stoichiometric calculation, easy one. So we have reaction 3 and reaction 4. Reaction 3 is when the copper solution just added to this potassium iodide solution. So they will undergo a redox reaction, and the iodide will oxidize to iodine. And these iodines, it will combine with the starch and form blue-black. Then the sodium thiosulfate used to titrate with the solution. So when all the iodine's gone, then the blue-black will disappear. That's how the thing works. And for the H part 1, this question gave another value. So another student determines the mean title to be this one, and the concentration of the thiosulfate, okay, is 0.06. So means from this part onwards, we just follow these values. Okay, in order to get the amount of sodium thiosulfate, so we just use MV over 1000. So we get 1.041 times 10^23. This one, okay, easy. And from the equation in the reaction 4, try to get the amount of iodine. Okay, this one you just need to get the ratio. Because it's 1 mole of iodine react with 2 moles of thiosulfate, so means the moles of iodine must be half. So you use this mole, okay, over 2, you get this one, 5.205 times 10^24. Then part 3, you need to use the equation in reaction 3 to get the amount of the copper 2 in 10 cm cube sample. Okay, this one you need to go back there. Okay, so 1 mole of iodine react with 2 moles of the copper 2, so means it's double. So means here you just need to use the moles that you obtained just now, okay, times 2. Then this is the moles of copper 2, which is 1.041 times 10^23. Then part 4, calculate the mass of copper present in second sample of the powder brass. Okay, this one is a total amount, yeah. Just now is 10 cm cube. Total amount is actually in 100 cm cube of solution. So means in this part 4, you need to use the moles that you calculate in part 3 times 10. Times 10, this is a total moles of copper in the solution or in the sample. After that, use this mole times the molar mass of copper, you get 0.661. Okay, this is a mass of copper inside the powder brass sample. Okay, so the last part is the mass of second sample of powder brass was 1.05. Okay, calculate the percentage by mass of copper in the second sample. Very easy. You just use the one that you calculate just now, 0.661 over 1.05 times 100%. So roughly you get this. Okay, don't put this, don't put 62.96 because it's S3SF. So you must put 63.0%. Okay, that's all. Thank you.